Hello everyone. Today we shall discuss about the module 3. This is the syllabus of the module 3 where you will be studying the operational amplifier and operational amplifier application. So in the operational amplifier you will be studying about the introduction, the operational amplifier block diagram, representation of typical op-amp, schematic symbol, operational parameters, and these are the things which you can go through it. Okay. So let us discuss the topic one by one. So this is the textbook which you need to refer. Coming into an operational amplifier. What do you mean by operational amplifier? Operational amplifier is an integrated circuit that can amplify weak signals. Operational amplifier has two input and one output. Its basic role is to amplify and output voltage difference between the two input. So you can see the diagram of operational amplifier. Usually the operational amplifier what we take is 741 IC. So which has a non-inverting input, inverting input, power supply plus VCC minus VCC and an output. This is a symbolic representation of the operational amplifier. So today we will introduce our first integrated circuit element, the operational amplifier. You can see it has three terminals, two are input terminal and one is output terminal. The positive is called as non-inverting input terminal and negative is called as inverting input terminal. VO is called as output terminal. There are actually more connections to the device that are not shown. The device connects to the power supply which is needed for the proper operation as well as ground. So we have just in this symbol you can just see the input and output. There is an IC where you have plus VCC, minus VCC, ground and some more pins over there which is not been discussed in this slide. So coming into a block diagram of operational amplifier. So this is a block diagram of typical operational amplifier. So input, non-inverting terminal and inverting terminal are the two inputs that is given in the input stage, and there is an intermediate stage and level shifting circuit and an output stage where you will get an output. So coming into our input stage. So in the input stage, dual input, balanced output and differential amplifier. The input stage should have the following characteristics: high input resistance, low input bias current, small input offset voltage, small input offset current, high CMRR, high open loop voltage gain. And it also provides most voltage gain of an op-amp, input resistance of an op-amp. What do you mean by intermediate stage? It has a dual input, unbalanced output differential amplifier, drives the output of first stage, direct coupling DC voltage well above the ground level, increases the overall gain of an op-amp. So next is level shifting, or it is also called as shifting stage. So DC voltage level is shifted to 0 with respect to ground. It is the emitter follower with constant current source. Output stage increases output voltage swing, raises current supply capability of op-amp, low resistance, complementary symmetric push-pull amplifier. It should have the following characteristics: large output voltage swing capability, large output voltage swing capability, low output resistance, short circuit protection. These are the blocks of a block, what it will be inside the op-amp. So we have discussed all these things. Next is a pin diagram of an op-amp. So it has 8 pins. First pin is offset null, second one is inverting, third one non-inverting, plus VCC is a power, minus VCC is a pin number 4, plus VCC is pin number 7. 6 output, 5 offset null, 8 1 is not connected. So here we usually use only 2 pins, that is input pins, inverting, non-inverting. Output will be 6, and we also use plus VCC and minus VCC. We will be not usually using offset null, pin number 1, 5 and 8. Coming into a construction of operational amplifier. Operational amplifier consists of differential amplifier, a level translator and an output stage. A differential amplifier is present at the input stage of an op-amp, hence output consists of two input terminal. One of those terminal is called as inverting terminal and the other one is called as non-inverting terminal. Terminals are named based on the phase relationship between their respective inputs and outputs. Coming into the characteristics of operational amplifier: open loop voltage gain, output offset voltage, common mode rejection ratio, sleeve rate are the characteristics of operational amplifier. So there are few characteristics which we will discuss today. So open loop voltage gain. Open loop voltage gain of an operational amplifier is its differential gain without any feedback path. Output offset voltage. The voltage present at the output of an op-amp when its differential input voltage is 0 is called as output offset voltage. Common mode rejection ratio of an op-amp is defined as ratio of the closed loop differential gain AD and common mode gain. Sleeve rate of an op-amp is defined as the maximum rate of change of the output voltage due to a step input voltage. Types of operational amplifier. An op-amp is represented with a triangle symbol having two inputs and one output. Operational amplifier are of two types: ideal op-amp and practical op-amp. Impedance is the amount of resistance that a component offers to low current flow in a circuit at specific frequency. Coming into a characteristics of ideal op-amp. An ideal op-amp exists only in theory and does not exist practically. An ideal op-amp exhibits following characteristics: input impedance Zi, which is infinity, output impedance 0, open loop voltage gain is infinity. If the differential input voltage Vi is 0, the output voltage will be 0. Bandwidth is infinity. It means ideal op-amp will amplify the signal of any frequency without any attenuation. Common mode rejection ratio is infinity. Sleeve rate is infinity. It means the ideal op-amp will produce a change in the output instantly in response to an input step voltage. Characteristics of practical op-amp. Practical op-amps are not ideal and deviate from their ideal characteristics because of some imperfection during manufacturing. And practical op-amp exhibits the following characteristics: input impedance Zi in the order of mega ohms, output impedance in order of few ohms, open loop voltage gain VAV will be high. When you choose a practical op-amp, you should check whether it satisfies the following condition: input impedance Zi should be high as possible, output impedance Zi should be low as possible, open loop voltage gain AV should be high as possible, output offset voltage should be low as possible, the operational bandwidth should be high as possible, CMRR should be high as possible, sleeve rate should be high as possible.